The overall goal of this procedure is to prepare and demonstrate an experimental setup for trapping ytterbium ions that includes a microfabricated chip.
Ion trap technology has been considered as one of the leading candidates for physical implementation of quantum information processing.
This procedure provides the detailed protocols for microfabricating a trap chip, as well as for constructing an experimental setup to trap ions using the microfabricated trap chip.
Ion trap systems developed by the microfabrication technology provide great potential for quantum information processing and quantum computing. And the protocols presented here will guide through the fabrication process and setting up ion trap experiments.
Visual demonstration of this method is critical because it requires orchestration of various components such as lasers, imaging systems, a vacuum chamber, electronics, and microfabrication.
To perform the experiment, one first needs to fabricate the surface ion trap chip. This is an example of a chip mounted in a carrier that is used in this demonstration. The chip's features are represented in this schematic. There is a loading slot through which neutral atoms are introduced. On either side of the loading slot, there are radio frequency electrodes to confine ions in directions perpendicular to the slot. DC voltages on the outer electrodes confine ions along the slot. DC voltages on the inner electrodes help tilt the principal axes of the total potential. For the experiment, mount the packaged chip in an ultra-high vacuum chamber. In this case, the chip is at the center of a spherical octagon chamber.